So welcome back. So in this video we are going to understand the React environment. So I'm going to be explaining it. So after we finish installing our React using Vite and we run our npm install, then by the time we open it on VS Code, we are going to see this basic folder structure. So let me zoom in a little. Okay, this is better. So now I'm going to explain these folders in the order of at which they are related. Then I'm going to explain also the files too in the order at which they are related, so that you can group them in memory just like that. Then before I do that, I want to explain what a React package is. Now in React, a package is a collection of files that have been bundled together into a single project. In other words, they are reusable codes designed by a person or group of persons that makes you build a project faster. So virtually everything that I want to do, or most of the things that I want to do on a website, they have a package that makes that very easier. So another way to think of a package is like a reusable function. For example, in our JavaScript, I have the console.log. So that is a function that is given to us by JavaScript out of the box. So a package is the one that other people write and make it free for you to use, so that to speed up your development process. So where can we find these packages on our React project? We can find them inside the package.json. So if I open the package.json, Z to break, so I'm going to see this JSON file. And by the way, JSON stands for JavaScript Object Notation. So inside this, I will see some details. Then next, I will see script, which is very important. So the package.json holds script and dependencies that your React needs to work, and that is what dependency is. So to depend on something means you rely on something. So the packages are like dependencies. They are like the backbone. If a dependency is missing, once you access a page that uses that dependency, then the React application will crash. So in order for React to run, we need to install the dependencies, and that is why we did our npm install. Now that is what the package.json is. It holds the list of dependencies that our React application need to run correctly. Now what about the node modules? It's also related to the package.json. So the node modules, why the package.json hold the list, the node modules hold the details of how those packages should work. So just a simple illustration to make this point clearer. So you know that when you buy maybe like a beverage, a drink, or even biscuit, or anything that is being processed, you will see the ingredients that beverage contains. So it can contain sugar. So let's say like Coca-Cola, for example. Now it can contain sugar, contain this, contain that. So that is just the list of the ingredients that a Coke contain, or a Coke brand contain. Now that is like a recipe. Now, do you know how to apply those ingredients to get exactly the same taste? Well, that is a detailed explanation. And for some recipe, just like that of just like that of Coca-Cola. It has been hidden. It's only a few people in the world that knows it. So it's not something that you can just guess. So that is a recipe. So the full details of how to apply those ingredients that you see on the bottle to give you that unique Coca-Cola taste is described, we can say it's described in the node module. So it's only a few people in the world that knows that. It's a trade secret. So the package.json holds the ingredients or the recipe list. Then while the node modules hold the description of how to use the recipe to get exactly the same test each time you want. So that being said, if we don't have these node modules and we have the package.json, we can also reproduce this. And that was what happened when we did our npm create Vite app. We have from the public folder down here, but we don't have the node modules. But by the time we ran npm install, it gave us this node module. So in other words, if I delete this node modules here and I run npm install, I'm going to get it back. And this is the format you'll be getting any React project that you want to learn, or your React project that you push to your GitHub. By default, you see this git ignore here. So you know what git ignore already is. It's used to ignore files that I don't want to accidentally push to your GitHub. There can be files that are too large, just like the node modules, or there can be files that contain some sensitive information that you don't want people to see when they are learning from your code or when they clone your code. So you put them in the package in the git ignore. Then this ESLint is for some styling settings. Then you know what the readme.md is. This is used for GitHub still. It's used to explain what the project is all about, so that can be a motivation for people to look into your code, especially when you're looking for some collaboration or help. Then the package log.json holds a list of std dependencies and the source of the download, and it also has some security measures here. So if I create a simple project that I know that will be useful to many developers all over the world, and I want to use that as a bait to maybe hack their system or do something else, I can put a link here that will install a malicious script that can get some information or undo their system up. So if I change that here, you notice this integrity that is here. If this integrity does not match this resolve URL here, it's not going to run this script. So it saves you from that. So if I have that malicious intent, then when I run npm install, you know, it's to just look at the package.json and start installing all the dependencies from here and dev dependency. So if the integrity here does not match the resolved URL, it's not going to install it, so it's just going to skip it. So it then means if I delete this package.json log and run npm install, it's going to recreate it. So if the integrity matches this resolved URL, then it's safe for you, so it's going to install it. So we have seen that the package.json is related to the node modules, and the package.json is also related to the package.json log. Then we have seen the importance of the readme. Now the next page we want to go to is, or the next file is the index.js. Now we learned that React is a single page application SPA. so it doesn't need so many pages to work. You just need one. So it will dynamically inject the rest page, which are in form of components, into the web page. And just like I showed you earlier, you notice this is only the index, but all this other home, blog, and sign out and other stuff, they are all components that is being injected when I click on those links. So now this is an external script and it has a type of module. Now this allows us to use the ES6 functionality of importing and exporting file, and this helps us to split our code in form of components. Now the external script that links that this script tag is referring to it can be found in the source folder and in the main.js. So let's go to that script file. So if I tap on the SRC, I'll see my main.js. So this is the default import that you need to run a React app, and this is the app component, and this is the external CSS that styles the index.js. Remember, so if I open this and move, so remember that this inside this index.html there's an external script that is meant for it, and which is this main.js. So if you want to style this index.html, you use this CSS, which is this index.css. Now when you're using React to render to the DOM or to show a page on the browser, you need to pass this through this long process. Now you know what this means. They are targeting this root div that is here, a div that has an ID of root. Then they are now rendering it to the page using a component. I also learn what a component is, but the name of this component is what? App. So it then means if you are using React, you want to render a page to the DOM, you must pass through this long process. But because of this idea of rendering a component, which is called app, you don't have to repeat this long process. So that means anything that you want to be shown on your web browser will pass through the app component. So like I usually nickname it, the app component is our window to the world, or is our window to the browser. So if you want to prevent coming to this main.js and adding so many things inside this main.js, you use your app, you pass through your app component. There are a few things that we can add there just to reduce the codes that we have on our app.js, and you see some of those things in a moment. So next we now want to move to the app app component. So I believe by this time you're understanding React environment. So you notice how the index.html is linked to the main.js. I notice how the main.js now is linked to what? The app component. So let's move to the app component. So inside this app component I have the import, and just as I explained, this import is made possible by using this module export here. So now this is a functional component, and for us to see what is happening here, let's now start this React application. So I'm going to click on this my terminal icon here, and I'm going to type npm run dev. You remember that is what Vite says you should type to start up React in the development process. So that has opened. So I'm going to press Ctrl. I'll hold my Ctrl, hover over this link, click follow link. So it's going to open Vite on my browser, my default browser, which is Chrome. So this is a simple React. Now Vite plus React. Now this is a button here. So if I click on this, you notice that the current state increases without having to refresh this page. So this is the beauty of React. It runs faster. Okay, so let me explain this app environment so that we can know how to add our own code, because this is not our project. So we want to do our own project, so or learn about React, so we need to learn about the environment. Now let's go back to the slide. Now we've learned what a package is. Now what is JSS? Now JSS stands for JavaScript XML, which is extensible markup language. Now JSS allows us to write HTML in React easily or in JavaScript easily. Now if you want to write HTML with JavaScript, let me demonstrate how painful that can be or how slow that can be. I'm going to write document, which is not a recommended code for you to write, dot write, and I'm going to put my string here, put h1. See how slow it is. There's no IntelliSense from VS Code because it's inside the string. Then hello world, then I'll close it. Now if I save this is going to clear everything on my browser, so that is why it's not good. You see, it shows me hello world twice. So this is how painful it can be. Now what if I want to write a paragraph below this? You see how painful it can be. So using JSS reduces this slow process of writing HTML inside the JavaScript environment. So just a way to help you differentiate between the JavaScript environment and the JS environment inside a component. So this is a JS environment. So if you come inside a function here, so let me do that up. You have a JS environment here, so you can add any valid JavaScript here and here and it will work. Now inside this return is a JSX environment. Then when you go outside the return, you have your JavaScript environment. If you go outside the function, you have your JavaScript environment. So inside this JSS environment, we can write a valid HTML with ease and it will work. So if I come here and type my h1, you see I have the IntelliSense just like it will do on a normal HTML file. Then I can type hello world So you notice how easy it is. So if I go back to my browser, the old content will show. I think I have to refresh this. So you see the hello world I've shown above, and you have this. So you see how easy it is to type. Now JSS has some rules so that you will not have issues with it. It has some rules. So let's see how some of those rules is applied, or means let us go through them a little. So some rules of JSS: you use your image component like this, or your image tag like this instead of this. Now to write JavaScript inside a JSS, you must write it inside a curly bracket or a curly braces. So for example, if I want to write H1 React is 10 times faster with JSS. Now inside this environment, this is a JSS environment, but 5 plus 5 is what? Is 10. So it's going to resolve this to be what? 10, and output React is 10 times faster with JSF. So let's try that. So I'm going to type another one. H2 React is 5 plus 5 times faster with JSX. So if I save that, it's going to resolve as React is 10 times faster with JSX. So you see how that works. So that is the first rule. The first rule is that, or that is the second rule, that when you want to write a JavaScript inside a JSS environment, you must put inside a curly bracket. Then the first rule is, for a self-closing tag, you must put a slash before the end of the angle bracket. Not like this that we do in vanilla HTML. So the third rule is, when rendering more than one element or a tag, put them inside a common parent or a fragment. Now an example is this. You know that inside a component, the return marks the start of the JSX. So I want to return paragraph 1 and paragraph 2. I must put them inside a common parent, which is div, or a fragment, which is an empty tag without a name. That is just a React syntax. You don't have, if you try this in vanilla HTML, it will throw an error. So let's demonstrate this. So if I go back to my browser, I want to comment out all of this. I want to remove all of that. So let me minimize back. So beginning from this fragment, so I want to remove that. So now if I type H1, now let me type P1, P, so this is para 1. So you notice I'm just returning a single paragraph, and that will not throw an error. This is para 1. So remember, the rule says when you are returning more than one tag or element, you must put them inside a common parent or a fragment. So if I go back, so let's say I want to add a new one. So I hit enter again, and I put P. This is para 2. Now even if I put the bracket here and close it here, notice the error is not fixed. So it's showing you here that now if you look at the IntelliSense, GSS expression must have one parent element. So that means if I highlight these two tags and put them inside a common div, just like this, you see React has stopped running and the error is gone. So if I do that, I will have this. Then another way is to put them inside a fragment. But before we do that, I want to inspect this page. So if I inspect this page, so that you understand the difference between a fragment and having a common tag that has a name. So if I inspect this page, I move down, you notice I'm having a div that has a para 1 and para 2. Now if I use a fragment, you see that this extra div is showing on my HTML, or if you want to use it in JavaScript, then it's showing it's being added to my DOM. So if I use a fragment, now the work of a fragment is, if you don't want this extra div to be added to the DOM, but just because you cannot output more than one tag with React, you just use it to solve that problem. So the fragment will not be added to the DOM, so this will be added directly inside the div, so there will be no extra div inside. So let me demonstrate that now. So if I remove the div and save, notice how it looks on our browser. So you see the extra div has gone out. So you know, anything that has advantage has disadvantage. So using a fragment will not add an extra div inside your documentary, but for the sake of styling this to paragraph tag, then the benefit of putting it inside a common parent tag, which is not a fragment, is important. So that is the third rule. So now the fourth rule is use class name instead of class. And why is that very important? Because remember, a component is still JavaScript and class is already a keyword. So the way the React team solve that problem is they use class. So when a compiler, if you say when React compiler is converting the JavaScript into a format that your browser can understand, it will replace this class name with what? Class. So that is rule number 4. You don't use class inside React, you use class name. Then if statement must not be inside GSS, but you can use a ternary operator. So in summary, GSS makes writing HTML in React very, very easy. It feels like writing your HTML inside a HTML page. So having understood the folders and the files, okay, there are some folders that we have not explained, which is the assets folder. Now this assets folder, you can use it to add images that your browser can easily access, especially if it's your own custom image, not the one that's coming from a server. You can add them here, or you can also add them inside a public folder, but because we are using Vite makes it easier for us to add it here. And this one here is very, very important, so I would not have to cd out of this, because where we'll be creating all our components will be inside this src folder. So you see that the src folder is the root or the source of most of the core ingredients of this our React project, and that is where we have our own custom component, as you will see in a while. So we have explained what this React environment is, what the node modules is. It holds the details of the dependencies inside the package.json. Then the source, the source folder holds the app component, the main and other important folders where we'll be working with. Then the public folder, we can put our images here or inside the access folder. Then we've also learned or we have been reminded about the importance of git ignore here. For one thing, is going to ignore this node modules because it becomes bigger and bigger as we install packages. Remember, it holds the details of how a package should run. Then we've also learned about some of the rules of JSS. Remember, to write a valid JavaScript inside a JSS environment, you have to do what? You have to use a curly bracket. So that is it for this React environment. So in the next video, we are going to learn about React component. What is React component and how we can create our own custom component. So see you in the next video.